Optical path length. This is a very important topic in optics. The geometrical wavefront that I explained it before is described as a surface where the optical path length is the same. So with another definition, I said the geometrical wavefront is a surface that we have the same phase. So the optical path length is equivalent to the phase of the light. Now let's talk about what is the optical path length. Optical path length, or OPL, has a very simple definition. From point A to B, if you multiply the refractive index times the distance, small distance, and you get integrate over all the distances, then you can find the optical path length. So this is for continuous material when the refractive index is continuously changing. But for discrete material that the refractive index is changing discretely, you just need to multiply n, the refractive index of each segment, times the thickness of that segment, and get sigma over all the different lenses. Now let's look at one example to understand it better. Let's say we have two pieces of glasses, different materials. The refractive index of material 1 is 1.6, the other one is 1.8. The thickness is 8 cm for D1 and the thickness is 4 cm for D2. Based on the definition, the optical path length is equal to N1, which is 1.6, times D1 plus N2, which is 1.8 times D2. Now let's take a look at the optical path length in glass 1. OPL1 is equal to N1 times D1, which is 1.6 times 8, equal to 12.8 centimeter, because the refractive index is unitless. OPL in glass 2 is equal to N2 times D2, which is 1.8, the refractive index, times 4 centimeter, the distance, is equal to 7.2. Now the total optical path length is equal to OPL1 plus OPL2, which is equal to 12.8 plus 7.2, which is equal to 20 centimeter. So when we look at the system, these two optical glasses, the distance is 8 plus 4, so the total length is 12 centimeter. Why the optical path length is 20 centimeter? What is the physical meaning of that? So you can pause the video and think about it right now. So the physical meaning of optical path length is that, as I mentioned before, the refractive index is the ratio of the speed of light in vacuum over the speed of light in your material. So for example, when the speed of light in a material which has the refractive index of 1.6 is smaller than the speed of light in air or vacuum by a factor of 1.6. So the speed of light in these two materials is not the same as the speed of light in vacuum, and the speed of light is lower. So if you start at one point, you have two beams that one is propagating through these two glasses, and you have another beam that is propagating through air or vacuum. One definition is that at the same time, the one that is propagating when the light started from here and get to the end, the other beam of light that is propagating through vacuum is traveling 20 centimeter. So that's one way of thinking about it. Or we can say when you start from 8, this is 12, if you start 8 centimeter before that and you propagate the light from here and here, then they're gonna get to the end of the material at the same time. So that's another way of thinking about optical path length.